Can you do question one? My screen is a bit weird. 14 of you. Okay, I think all here. Okay, let's look at tutorial 2, question 1. So that should be easy, right? Maximum value. So Vmax. Vmax 359.3 watt. Imax 100 M, right? Then the RMS value. So we use VRMS. So equals to Vmax divided by sub2, right? So you get 254.1 watt, and here IRMS you use 100 divided by sub2, so you have 70.71 M. Any question? Then the phasor expression. So for voltage, it will be RMS 254.1. Then angle, because I think voltage is in cos, so you straight away can take angle 15. When I is RMS value 70.71 angle. So because it is sine, so you need to use 5 degree minus 90 degree. So it will be negative 85 degree. Okay, so this will be the angle for voltage, and this will be the angle for current. Any problem? I think it should be okay, right? If no problem, then I go to question 2. If you have anything, then you please stop me. Compute the phasor I1, I2, and voltage. So your I1 here, I2 here. I hope so we can use the yeah, they tell you the total current. So you can use current dividers rule, right? Current divider rule. So we have I1 equals to 10 angle 0 degree. So current divider rule, you want to find I1, then you need to use the opposite side. Negative 6J over 8 plus 6J minus 6J. You okay? So this is a bit about second analysis complex number chapter. Yeah. So you need to know how to do the complex number using your calculator. Okay, you don't need to show me the steps. Calculator, settle it. Okay, change your calculator to complex number mode, then you straight away can press it from your calculator and get the answer. Anyone have problem with this? You can let me know, that I can show you how to get from calculator. So the answer should be I1 should be 7.5 angle negative 90, and I2 should be total current minus I1. You can use a total current here minus I1, then you get your I2, right? So you should get 12.5 angle 36.87 degree. And then voltage. So once you have current I1 and I2, you can find voltage easily, right? Use V equals to IR. So you can use either side, I1 with 8 plus 6J, or I2 with negative 6J. So I use I2 with negative 6J, then I will get 75 angle negative 53.13 degree watt. Phasor diagram, I won't really ask, I no need to do, is okay. But if you want to see how to draw the phasor diagram, yeah. After you get I1, I2, and voltage value, so you just draw the phasor diagram according to the values that you got. 0 degree here, negative I1 is negative 90 degree here. the imaginary and the real part, but not important. Phasor diagram is not important at all. Any problem? Any question? Now only I can see your message. So then why ask question 6, 8, 9, 10? Okay, all those questions are the more complicated questions. Can I? Question, can I jump to? actually, I wish to jump to question 6. Never mind, we will discuss all. We can discuss all, no problem. Okay, so question 3. Okay, we go slow. We go slowly and no rush. So that's why I think I will complete all the discussion for all the questions in tutorial. No need to skip. But then, of course, if you have a question, then I will discuss more on the questions that you ask. So this kind of easy question, I will go quite fast. Yeah? So question 3, let the 100-watt sine wave source to be connected in a series combination of 3 ohm resistor. This one need to be careful. Okay, 8 ohm, okay. They give you the ohms, then okay. Not in Henry and Farad, then okay. 4 ohm capacitor, okay. Draw the circuit diagram. So the circuit diagram should be something like this. Okay, series, because they say so, right? In series. Okay, source and resistor, inductor, capacitor in series. Okay, then compute the string impedance. Very easy, right? Okay, so you draw in series, then total impedance equals to all the impedance add together, 3 plus. So they give you 8 ohm, but then you need to know it's impossible to write 8 for inductor and 4 for capacitor, right? So you need to know that inductor should be equal to 8J and capacitor equals to negative 4J. So this is as I say, the question is not tricky. It's not difficult, but it may be a little bit tricky, like this kind of trap. So last time also I have a midterm test, one of the year. Then I give something like this: 8 ohm inductor and 4 ohm capacitor. Then a lot of good students, they make a mistake. Then they forgot to put the 8J, and some they put 8J and then 4J without the negative sign. So most of the good students cannot score. But the question is actually very easy. Okay, so I give you 8 ohm and 4 ohm capacitor. You need to know that you need to put negative for capacitor. Okay. So basically, okay, what is the question after that? Series impedance should be okay, right? Determine the current delivered by the source. So if you already have the voltage source and the impedance, you want to find the current, should not be a problem, right? Okay, so it will be I equals to V over total impedance Z. Okay. Here I don't know. I don't know why the color cannot maintain a red color. Okay. So basically just like that, then you get it. Then because the current right, like voltage source by 53.1 degree, so power factor is cos 53.1 degree, 0.6 lagging. But actually you can also do this. Power factor formula is actually power factor equals to what? Cos theta v minus theta I. So cos theta v voltage is 0 degree, right? Minus minus 53.1, so it's plus 53.1 degree. So you cos 53.1 degree, then you get answer. So how to know lagging or leading? So that I give you the summary table, right? So if current lags voltage, then it's lagging. Or you can actually look at from here. Actually the capacitance and the inductor, right? So it is more to inductive load, right? Because you have higher inductance. So J8 minus J4, you still have J4. So it is positive. So it means it is QL, so capacitive load. So you should be lagging for capacity. So sorry, inductive load. So it should be lagging for inductive load. As I stated in the summary table that day. Do you know which summary table that not the extra power factor three phase summary here? Nah, lagging. I lags V inductive load. Okay. Any question? No question. Then we go to next question. Okay. Question 4. This question 4 you need to be careful because I told you millihenry. Yeah. So you have to change it to ohm. So how to change inductive inductance to ohm? What is the formula? It's time to ask. WL omega L, okay, 2 by FL, yeah, 2 by FL. So that you change it to XL. So determine the power factor of the circuit and state whether it's lagging or leading. Then determine the real and reactive power. This one I don't want to show you my answer. Yeah. So first of all, you have to know what is your Z, because you have R and L, right? In RL series RL circuit, so you need to find out the total impedance. So it should be Z should be what? R plus JX, right? So resistance will be 10 ohm here, then plus JXL will be like what your friend said, 2 by FL. So 2 by, oh yeah, 2 times pi. 2 pi times with 60 hertz, right? Times 40 milli. So basically you have 18.1 angle 56.4 degree. Okay. Then from this actually you can't know but about the power factor. So you need to find out current first. I will be equals to what? I will be equals to V over total impedance. So from here, 120 angle 0 degree divided by impedance value 18.1 angle 56.4 degree. So you are going to get current 6.63 angle negative 56.4 degree, right? Can you get what I mean? From series impedance, then you get current. Current equals to voltage divided by the impedance. Then you get the current value. So from this current value, then now you can determine the power factor. As I told you just now, power factor equals to cos theta b minus theta I. So we cos theta b is here 0 degree. If they didn't write anything at this kind of question, they write RMS, then definitely 120 is RMS. You don't need to divide it by SUT2 anymore. Okay. And then without anything, it means the angle will be 0 degree. Okay. Then 0 degree minus theta I. Theta I will be negative 56.4. Negative, you get positive 56.4 degrees. So which is 0.553 lagging. Are you okay? Any question? Then determine the real and reactive power. So after you have the power factor and voltage and current, right, you should be able to find power. Okay, so power right here. So I will write complex power, S equals to VI conjugate. Okay, so V will be 120 angle 0 degree, right? Then I will be, this one 6.63 angle negative 56.4 degree conjugate. Are you okay? So when you press calculator, you can press 120 angle 0 degree multiply with 6.64 angle positive 56.4. Then you don't need to care about the conjugate. Conjugate itself is only change in sign negative to positive or positive to negative only. Sign of the angle. Okay? So of course, calculator itself also have this conjugate function. So you can use a conjugate function. If you use a conjugate function, then you need to press a negative. If you don't want to use a conjugate function, you want to straight away press it, then you press 120 angle 0 times multiply with 6.63 positive 56.4 degree. Positive power factor is lagging. Not because of positive power factor that is lagging. Okay, it is because of this one theta. Where's the summation? Lagging or leading is determined by this. Okay, I lags V. So now the angle of I is behind angle of V, right? Because I is negative 56.4 and your V is actually 0 degree. So if according to this, then it should be lagging. And this question very clear already is inductive load lah. L inductive load. You don't have any capacitive load, so it must be lagging. Edin, did I answer your question? Understand, right? So from here, if you get from calculator, can you try to get to calculator? You are going to have what's the value that you are going to get from calculator? Four 440 440 plus J 663. You should get something like this. You should get something like this. Okay, when you get from this, then you will get I believe you get in polar format. Then you need to change the polar format into rectangular format. After you change it to rectangular format, then they say they want to have real and reactive power. So real power is P, reactive power is Q. So P will be equal to 440. These are real part 440. Q will be equal to 663. This one, imaginary part. So that the unit with W and VAR. Any question? So for real and reactive power is actually very easy. Okay, real and reactive power is very easy. You just use S equals to VI conjugate. Okay, voltage value, current value, conjugate it. Then the conjugate is only for current, yeah. The conjugate is only for current. Okay. Then change your answer into rectangular format. Rectangular format means you have the real plus minus J, then imaginary part value. So the real part will be your P, the imaginary part will be your Q. Any questions? Anyone can understand this? Kibun? Minghang? Ryan, can you all? Yingshen, can you all understand this? That's good. Then we go to the next question. Done, right? So real and imaginary, real and reactive, and as we call complex power, then we have real power, you have reactive power. Okay, so apparent power, okay, since we talk about this, what is the apparent power? This one, when you change it to, if you change it to polar format, what will be the answer? 440, 440 plus 663 J. If you change it to polar format, it will be 795.72 angle 56.4 right degree, right? So from in the polar format, the information will be what? The magnitude will be apparent power. Apparent power symbol like this. Magnitude of S. Apparent power. Then the angle of this S, right? This complex power, right? The angle 56.4 is actually the power factor. Okay, so you can actually cos straight away. You cos 56.4, cos 56.4, then you get 0.553 like this. So from this S equals to VI conjugate, they will tell you all information: P real power, Q reactive power in rectangular format, and apparent power and power factor in polar format. So you are going to have 4 information in one formula. Okay, this is what I want to tell you. If you are okay, then we go to question 5. PF, yeah, PF is power factor. Any question? So let's look at question 5. Okay, there will be one questions about power triangle in your I can't remember your test or in your final. Okay, it's about power triangle. Okay, so if I say determine the power triangle, it means, what does it mean? It means I would like to have this. Okay, don't just draw me a yes PQS. Don't and power factor. Don't draw me a triangle without anything. So you need to give me the information here, here, here. Okay, write down the value. Okay, it's better with the unit and the symbol as well. Q equals to what? P S. Okay, and the power factor value. So determine the power triangle. It means something like this. Okay. So yeah. So and that, okay, can now this is one question. So how are you going to get your V and I? You can't do like this, right? You need to change it in the format, right? What value, angle, what angle, right? So how are you going to change it to this? Ying Xuan, any idea? Yeah, what thing that you need divided by something? Brian Tan? Brian, you have two devices, is it? Two devices, right? Wow, Brian, you are very hardworking. Oh, you need two devices, ah. That means one for recording, ah. Wow. Yeah, rich and hardworking. By the way, that means one of you, if two devices, I should have 14 students, right? That means deducted from my two devices. That means one of you is absent. Hui San is busy today. Okay, just take full attendance. No, I want to show that I'm responsible and I care about you, that whether you are attending my class or not. Yeah, in order to score 5 stars, all right? Okay. Yeah, so one of you, Hui San, is absent today. Okay. Wait, so how are you going to do this? Power triangle. Yeah, so you cannot write, can you, okay, what I want to say is, can you write this 150 angle 10, and this one 5 angle negative 50 degree? Can you? Yes, you need to divide it by square root 2, because this normally only in this format you need to divide by square root 2. Other than that, normally no need. Okay, so first of all, V equals to 150 divided by square root 2 angle 10. Then I equals to 5 angle 5 divided by square root 2 angle negative 50 degree. I try my best to write as nice as possible. Okay, okay, then you can use the formula S equals to VI conjugate. So multiply the both of them. I conjugate means instead of -50, then you key in 50 degree. Then you should get the answer. So you should get 375 angle 60 degree, which is equivalent to 187.5 plus J324.8. Okay, so power triangle. So your power triangle should be something like this, right? Okay, so P will be here. P will be 187.5 W watt. Then Q here, right? Will be equals to 324.8. Okay, so S here will be equal to 375. So angle here will be the 60 degree. Yeah, this 60 degree will be here. So from one formula, S equals to VI conjugate, you can know 1, 2, 3, 4, 4 information. Then find the power factor. Okay, so power factor will be equals to cos 60 degree. So you're going to get 0.5 lagging. Okay. How you know it is lagging? Again, it should be it should be very easy. From this positive Q, positive Q, yeah, positive reactive power. It means it should be positive Q. Okay, positive reactive power. It means this Q value positive. It means you'll be lagging. It should be inductive load. Okay, you get it. And other than that will be the leading lagging things. You can see voltage is positive, angle 10, then current is -50 degrees, so it's I lags V, so it's lagging. Okay, then part C, calculate the reactive power supplied by the capacitor in parallel with the load that correct the power factor to 0.9. So now the original power factor is 0.5. So when they want to correct the power factor to 0.9, so what we need to do first? So it will be cos theta nu equals to 0.9. So theta nu will be shift cos 0.9. So you need to this one will be 25.84 degree. Then normally I ask the student to draw a new power factor. So this one will be theta nu. This one will be P. This one will be Q nu. So from this you will know you need to use sine, cos, or tangent. It should be tangent, right? Tangent theta nu will be equal to Q nu over P. So your tangent theta nu 25.84 degree equals to Q nu is the value that you want to find. P. So this P value, okay, because you add in the capacitor, you only will affect the P, the Q. So the P will remain the same. P is for resistance. So P will remain the same, 187.5. So 187.5. So from this, you are going to get Q nu equals to what is the value? 90.81 VR. So QC, the capacitors that the capacitors that the reactive power for the power for the capacitor that you add in order to correct the power factor to 0.9 will be QO minus Q nu. O value will be this 324.8. New value will be this 90.81. So you must deduct them, then you are going to have 234 VAR. Any question? S equals to VI conjugate. Yeah, S equals to VI conjugate. Any problem, Eddie? So this is how we do it. Power factor correction is is a very yeah, hot questions. It means you will often see it in the past year questions, as well as in your test or exam. Okay, Nicholas, are you okay? You all learned this before? I think for electronic students, they learn before in E-Tech paper, right? Oh, not until power factor. Okay, so I think roughly okay, right? It's very step by step, right? So basically, you need to draw two power factor. So one will be the old one. So you determine the value of S, P, and Q. Then another power factor for new one. Yeah. Then tangent it only. Okay. So every time I use a power factor and power factor improvement questions, I will use this method, this solution, and never change the solution. The way of doing, no need to change. It's just like that. Okay. Okay. So if no questions, then adding one question. Meaning need to add 2, 3, 4. Yes, means you need to add in the capacitor in parallel to the circuit. Then the capacitance Q value is not capacitance value QC. Okay, the power reactive power for the capacitor is 234 VAR. So this 234 VAR later on, yeah, will make your Q new to this value 90.81. So that means your power factor now will be equals to 0.9. If you have Q new equals to 90.81, then with your power which is 187.5, that means your power factor, if you tangent them, then you should get tangent them and then cos the theta, okay? Then you should get 0.9. Adding, can you understand? That means this is a way how people improve their power factor. Yes, capacitance will reduce Q. But then the problem is most of the factory or industry in the industry, right? They are using all the motors is actually inductive load, so they are having a lot of inductive load. So in order to reduce the inductive load, which means to improve the power factor. That means we need to put in the capacitors. And I already told you right why you need to improve the power factor. Okay, if not, then you are going to TNB is going to supply higher current, okay, with low power factor. Higher current will means what? You are going to have a bigger cable size and everything will be costly. Protection system also need to be more complicated because of high current. Okay, so that's why they encourage us to have a high power factor. Maximum will be 1, right? Because you cos 90 degree will be 1. Okay, maximum power factor will be 1. So 0.9 is considered high. Household, of course, no penalty. Yes, only for industry. Industry commercial also rare. Normally industrial. Like those big factory run a lot of motor. Yeah, household definitely not about this kind of power factor problem. Okay, so for industry electricity bill, they will have one section for power factor and the maximum demand. Bypass meter. I hope so. I hope my electricity can bypass meter as well. Then I can always on my aircon. Hmm. Okay, then next we go to question 6. Question 6 is a bit different. Have you all tried question 6? Okay, look at question 6. Yeah, it's again about the but okay, one question is why sometimes they say kVA, sometimes they say kVR. Okay, because if you only have one thing, you only have one component, so S equals to P plus JQ, right? Okay, so if you only have one component, you don't have this P, so that's why your S and Q is basically the same. So some students ask why kVA, not kVAR. Okay, so actually that makes no difference. Do you get what I mean? Okay, so this is actually not the main point lah. Don't care about this. Jianji, you find out what's the power you want to write kVR also can, the power value for the capacitance. So to improve the power factor to 0.9. So for this question, basically they tell you, if you want to draw the power triangle, right? So they already tell you P here equals to 500K. Then QO you don't know lor. Then this one theta O you don't already, right? Theta O is equal to 0.6 power factor. So you need to find out from this 0.6 what is the angle. So you need cos theta O equals to 0.6. So theta O equals to shift cos 0.6. Any question? Oh, so why only try 6A? Oh yeah, 6B is a bit tricky, not the common way. So why is this shift cost 0.653.13, I think. Okay, so means from here you know already theta O, right? Then 500K. So can you know Q? So it should be tangent, right? Theta O. So like it's a right angle triangle, although I'm not really draw it straight enough. Okay, so theta O equals to QO over P. So QO is equals to P 500K. Okay, then tangent theta O 53.13 degrees. So from here, calculator settle, you are going to get QO equals to 666.7 kVAR. Okay, then Q okay already. Then how about Q new? New one now you want to improve to 0.9. So again now you cos theta new equals to 0.9. So theta new equals to shift cos 0.9, 25.84 degree. Then you can draw another new power triangle. So P here, Q new here, then theta Q new here. So tangent theta new equals to Q new over P. So what is the P value here? What is the P value? Tangent theta new, you know, right? 25.84. Q new is the thing that you want to find. Then what is your P? Yeah, 500K. Again, P is always the same. Yeah, new and OP is always the same. Then from here you get theta new, Q new equals to 242, is it? 242.2 kVAR. So QC equals to QO minus Q new. So equals to 424.5 kVAR. VAR or VA is okay. Any question? So this power factor improvement question, I think already, yeah, nothing much. Okay, so you should be able to do it. Part B is something different. Okay, part A I think should be okay. If you have any problem, then you let me know. If not, then I assume you're okay. So part B, calculate the resulting power factor if a synchronous motor rated 500 horsepower with 90% of efficiency operating at rated load and at unity power factor is added to the plant instead of the capacitor. So assume constant voltage and 1 horsepower, they tell you is 0.4746 kilowatt. So what does it mean? Normally we will add a capacitor to improve the power factor, right? Now they say they don't want to add a capacitor. Instead of it, they add the motor. Okay, the motor value is 500 horsepower, which means you times with 0.746 kilowatt, then you get the wattage value, the P value. Okay, and then 90% of efficiency. Okay, at the rated load. Okay, then the unity power factor. Unity power factor, it means the power factor equals to 1. Unity power factor means power factor equals to 1. Okay, then now, do you understand the question? Okay, they want to know what is a power factor now. So they want to know what is a power factor after you add in the motor, and the motor spec they give you like this: 500 horsepower, 90% efficiency, and unity power factor. So how are you going to do it? So first of all, you need to know the power P value for the power. So it should be 500 times with 0.746 divided by 0.9, which is equal to 414.4 kilowatt. Are you okay? Yes, Q is motor is basically equal to 0 because of unity power factor. Because of the efficiency, 90% efficiency. So this 90% efficiency, it means your 500 times with 0.746, right? This one nothing, right? 500 horsepower times with 0.746 k to change it to kilowatt. Then it means that this one is actually 0.9. So we would like to know what is 1. So the original value. So that's why we need to divide by 0.9. Yeah, like what Nicholas said, actually a lot of us, and me at first also will multiply with 0.9. Then I found out actually everyone will divide by 0.9. They want to find out the original uh, 1 when it is rated 1. Are you okay? Again, this is not my answer. This is answer from the book. And yeah, a few book also states so that they actually divided by the efficiency. So I believe that yeah, the explanation should be this, that the value is actually 0.9 power factor and they would like to find 1. So when it is 100%, so we have to divide by 0.9. Okay, so that's why we get the original value 414.4 kilowatt. You okay? This is really a question that always students will ask, will insist, but as I said, this is not my answer. This is the answer from the book. So I always do this when they say X with certain percentage. Yes, you always do this when they say with certain percentage of efficiency. Okay. And what I can understand is the 500 horsepower should not be 100% because it is 90% efficiency operated at the rated load. So means that the load side is 90% efficiency. But when we do this kind of calculation, then we won't care about this load side. We will care about the supply side. Are you okay? So which the plant resulting power factor. Yeah, the motor sure will not use 100%. But calculation-wise, normally we will consider the ideal case, which is 100%. Okay. I can foresee this question because, yeah, actually, normally students will ask this. Okay, but as I said, I can try to get search from a few books. Actually, they also do this. They divided by the efficiency. Yes, yes. Calculation only want to look at the load effect of the motor. Not to say the load effect of the motor should be the origin of everything. You get what I mean? We won't really care about the load side is 90% or 80% or 50%. That is the outcome when we run it. But when we do calculation, we will look at 100%. Do you understand what I mean? Yes, the model is a load. The model is a load. I mean, we won't really care about the load whether only run at 90% or 50% or 80% or 10%. Okay, when we do calculation, we will treat it as 100. Means when we do calculation, we will treat it as 100%. And because I think, and because this question is actually targeted for plant. Okay, the resulting power factor is for the plant. Are you okay? Can you accept this? Motor absorb different amounts of power based on percentage. What percentage? Uh, percentage? You mean this 90% efficiency? Yeah, of course, of course. Yeah. So, but then now, you get what I mean. So that's why now the motor itself is only this one, 500 times with 0.746, which is around 373 kilowatt. So that is 90% is only 373 kilowatt. So, but as I said, when we do calculation, we will do one when it is 1 or 100%. This is 90%. So the 100% will be 414.4 kilowatt. Can you imagine? So we need to use this 414.4 kilowatt to continue with our calculation. Okay? Okay. I try to convince you. Okay? But as I said, sometimes it's hard to explain because this is the way that they do it. Okay? Yeah. Where are we? Okay, so after you get your p value, this is a p value of the model that you add in. Then basically, what is your, you can redraw the power triangle. So what is your power now? So it should be p equals to 500, the original, right? Plus with 414.4. So then the q will be remain the same like original q value here, qo, which is 666.7. 666.7 kVAR. This one will be 914.4 kilowatt. So from here, then can you get your theta? So tangent theta will be equal to what? Q over P. So from Q divided by P value, okay, then you should be able to get the tangent theta. So from tangent theta, so you can shift shift tangent theta in order to get the you need to get theta. Shift tangent this value okay, this value substitute in. then you are going to get theta value. Then you want to get power factor, cos theta, cos this angle. Then basically you get, do you get what I mean? 0.808 lagging. Yeah, let me do for you. 666.7 divided by 914.4. So it's basically here will be 0.7291. So you shift tangent 0.7291, then you get that's why tangent here, theta here you get 36.09. Then you cos the answer, then you get 0.808 lagging. Can you understand? So it's actually basically is nothing. It's just the same power triangle. Just that right now, instead of just now, your P remain right 500 and 500. But now, because they add in something, motor will affect the P value. So affect the P value means you add something off. So your Q remain the same. Then from the power triangle, you still will find able to find theta. So once you find theta, you want to find power angle factor is not a problem, right? Okay, any question? So far, so good. No. This one cannot correct power factor. Actually, it didn't correct the power factor. Did it 0.8 lagging? 0.6. 0. How come it improve? Supposing it won't improve. Supposing it won't improve. Just that the this one should be inductive motor. Okay. To improve the power factor, actually there are a few ways. From what Edin said, is also correct. Some type of synchronous motor also can improve the power factor. But then normally to me, I won't really care. I will look at the value. Okay, then it's improved to 0.808, then okay, then I say it's improved. But the common way of improved power factor supposing is at the capacitors in parallel. Okay, then in the industry, actually, they have one thing called power what you call power factor regulator, the capacitor banks. So it will automatically uh, change the value of the capacitance to improve the power factor. Shunt reactor can use, I think so. Okay, yeah, you can Google. There are a few ways of improve power factor. Of course, you can Google it. Okay, but the more common way is adding a capacitor. Okay, any question? If you're okay already, then we go to question 7. Can I skip? Because it's again about the power factor improvement. Question 7 is a bit spatial in terms of quick one. Let's settle all the power factor question. Okay, question 7 is a bit spatial is because they say they want to find net capacitance. So instead of in microfarad, so instead of in just now in VAR, right, the power reactive power. Then now they say they want to have the net capacitance value. Okay, so how are you going to do it? So again, you need to find this one will be PO value. Then cost shift cost 0.8 lah. Then you get 36.87 degree, which is your theta O. Okay. So once you have theta O, then you can have your QO, which is P tangent theta O. So quick one, I didn't draw the power triangle anymore. 37.5 VAR. Then they want to improve to 0.95. So means theta nu equals to shift 0.95. Shift cost 0.95, you get 18.19 degree. Then again, you can find your Q nu equals to Q nu equals to P value 50K, then tangent theta nu. So you have the value, I think it's 16.43 kVAR. Okay. Any question? 37.5 K. There's a K. Okay. Then QC is basically QO minus Q nu, right? So you deduct both of them, then you are going to have 21,000. Okay. J. Okay, this is with J. Okay. Yeah. Capacitance also is negative. Something like this. Okay. Then the capacitance itself, there is a formula, right? Q equals to V squared over XC. So which is equal to V squared over X. X itself is what? 1 over 2 by FC. So you want to know this C value, then you need to move around. C will be equal to what? V squared. Sorry. C will be equal to QC, this QC value. Okay. Divided by 2 by F V squared. Okay. So it is basically equals to 21070 divided by 377. 2 by F, 2 by, and F frequency is 60 Hertz. So it should be 377 and V value 220 power 2. So you get capacitance of 1155 microfarad. Are you okay? Any question? The V here is a peak value. The V here is a peak value. Peak value. No, I think it's RMS value. The only peak value or maximum value is something like just now. This one cos sign. Okay, normally they write here, then only it will be maximum value, the amplitude. Okay. Other than that, then all like this will be RMS value. Okay. So if you are okay, then we go to question 8. 9, 10. I'm sorry. Okay. This question 8, I think Why you ask, right? See, this one got a little bit of long story. Okay, okay, I need to find a way to explain to you. Okay, okay, can you tell me what's your problem? Let me see if you have the same thing as what I think. I give an answer. Okay. Anyone try? So actually the story is like this. Okay. All these questions is from a book, and then the book is actually not very consistent. Means sometimes you do one way, another time that you do another way. Okay, then it may confuse you. So the thing that is different is because this one 208 watt. Okay, so normally I think you confuse here. So a balanced three-phase 208 watt source supplies a balanced three-phase load. If the line current IA is measured to be 10 amp and is in phase with line-to-line voltage VBC, find the per phase load impedance if the load is Y connected and delta connected. Then okay lah, load side you have delta or Y connected. Then I think most of you will think, then how about the source? Right, the source is, as I said, you have like this, right? Three phase you only have source, line, and then the load. Okay, this one line and load. Okay, so then normally source side, they didn't tell you is Y or delta connected, right? Then how you know? So yeah, this is a problem, right? So actually it's like this. The source type is Y or delta actually doesn't matter. Actually doesn't matter. Because your load side is actually not looking at the source side. Your load side is actually looking at the line. So what does it mean is, normally if they didn't tell you anything, delta or Y, that means it is a line to line voltage. So this 208 is actually line to line voltages. Is that clear? So although they say source, okay, but actually it means line to line voltage. So means the source is delta or Y doesn't matter, because what you want to look at load, you look at what, the line. Okay, so the most important is the line. Okay, so the line is connected to the load, so the line voltages is more important. So you get what I mean? Can you understand? So that means that this 208 watt is actually be line to line 208. Then, okay, my answer, can I tell you not the answer from the book is actually like this. They use this 208, I believe you are going to be very confused. Eh, okay, this 208 is actually with the 30 degree. So they want to find it's actually with 30 degree. Then they want to find VAN. Because Y connected that means this is line to line. So you go in the Y load is with N. You get what I mean? Y load is with N, the neutral. So your line to line is definitely the voltage here is definitely not the same as Y line to line voltage. So you need to find VAN. So you need to use a formula. As I told you, you only have two formula. If it is not the same, then you need to use formula. So from this formula, line to line you know already, which is the AB. Then you want to know what is this AN. So it means what? What is the formula? So you need to use VAN equals to AB divided by sub 3 angle 30 degree, right? So which is V line to line divided by sub 3 angle 30 degree, right? You move around the formula here. You move around this formula to find VAN. Can you understand what I mean? And why you want to find VAN? Because Y load, that means N is here, your A here, B here. So line to line voltage is line AB, it's not AN. Understand? V line to line equals to VL. VL, where's my VL? No, I don't have VL. I have V line to line. Oh, VL are here, VL, right? VL. I have VL, meh? No, I don't have VL. What is your VL? Load voltage. Low voltage? No. Edin, can you explain what is your VL? LL means line to line. L means line to line voltage, means here. So normally line to line voltage, you only have 3 lines. We don't have the N line, so we have A, B, C line only. Line to line voltage means VAB, VBAC, or VBAC, or AB lah. Okay, so we look at one phase only. It means normally we look at AB lah, because the other two, it only 120 degree apart from each other. Can you understand? So we want to find V line at AN. Then now the problem is, so from here you substitute in 208, substitute in here, right? Then you divide, then you are going to get 120 angle 0 degree. Do you have any problem here? Okay. Okay. Why they want to say this one is 30 degree? It is because they want to fix this 120 degree 0 degree. Means the AN they want to fix it 0 degree as a so-called reference. So they say this one is 30 degree, although they didn't state, and it didn't state here that it is 30 degree, right? So then, but then they actually do something like this. Understand? Anyone have any problem? Okay, then the next thing will be, so once you have your VAN value, then this is okay. This one I said V line to line is AB lah, AB line. Then we have line BC. BC will be 208 angle negative 90 degree with the minus 120, minus 120, then you get negative 90 degree, right? So they say IA is in phase with BC. So it means that your IA is 10, then angle negative 90 degree, which is same as this angle here, 90 degree and 90 degree. 90 degree and 90 degree, okay? So now they want to know what is your load impedance. So you want to find Z. Why? No problem, no? Just use VAN divided by IA. Okay. Why? Because IA line A is here, IA is here. So your impedance is here. So as soon as you have VAN, A to N voltage, then you use a current IA, because it's only one line go in, right? One line go in. Okay, so then you can find your impedance. Ohm's law. So from here, you have 12.01 01 angle 90 degree. Okay, which is your J 12.01. 人家 asked already how 30 degree count. So you then no. Okay, it's actually like this. I purposely want to share with you this. It is because this is not from me. This is from the book. And if you refer to different book, they will have different reference. And what I want to tell you is, angle actually is not important. Angle actually is not important. You can actually assume the angle like this one. Because normally we will assume VAN is 120 angle 0 degree, right? So that's why they say they want to have this as a reference. So that's why the 208 they put in 30 degree. Because when you put in 30 degrees, the formula is divided by 30, then only you can get 0 degree. Can you put 40? If you put 40 here, then you won't get 0 degree, right? Because the formula is divided by 30 degree. Can you understand? What chincai put 30, 60, 120? No, you cannot chincai. You cannot chincai put 30, 60, 120. It's because of this 30 degree. Then we okay. And of course I should standardize the exam in the exam marking scheme and all that. I standardize so that's why I want to tell you, don't worry about this. If I want you to put 30, I will state 30 degree. Understand? So you just follow in the exam or test, you just follow the question. Question say 30 degree, you put 30 degree. Question didn't say anything, then you put 0 degree. Understand? In the exam or test, you follow question. If you are this, 120, 208, then you put 208 0 degree. Okay. So, but I want to share with you this. It is because this is from the book, and I worry if you read different book, then have different reference, then you confuse why like that. Why sometimes 30 degree, sometimes 0 degree? It is because of this. Okay. Yeah, this is so confusing. It's really true, but how to say, in power system actually the angle is not important, because the main thing is 1, 2, 3 line, right? 3 phase. The main thing is 120 degree apart from each other. As long as it is 120 degree apart from each other, so the angle value, you want to start with 30, you want to start with 0 degree, actually doesn't matter. That is the thing. So in the books, not only this book, other book also like that. So it can be, yeah, sometimes they may put follow the question 0 degree here. Sometimes they may put 30 degree, not following the question. But in your exam or test, you follow question. Okay, because I also don't want to, have put myself in trouble that different students have different answer. Okay, why don't worry, don't worry. Okay, in the exam or question test, you follow question. Okay, now you understand this. Then if it is a delta connector load, yes, if it is not 120, then it's unbalanced. So, but then unbalanced, then we have another chapter, unsymmetrical fault chapter. Then you will learn that. Okay, so far in three phase questions, and you will be balanced three phase. Balanced three phase. Yeah, if it is not under 20, then it's unbalanced. There's another way of solving it. It's not so related to this chapter. Okay, so if it is delta load, that means if it is delta load, that means what? Your line current, line voltage AB, then it will be same as this AB, right? This is load, this is line. So we no need to care about the source. Okay, so means your VAB here will be equal to V line to line law. Now you no need to change. Just now you need to change it to find VAN, right? Then here we use VAN. So here you no need. So you can straight away use a Z line. It will be equal to what? V line to line over correct. Yeah, IA. Okay, but the problem now is this IA value, this IA line, you cannot, it's not the same. You want to find this impedance value, you can use IA. You can't use IA, right? It is because the current come in, they separate the two, is not the same line. Just now is same line, go in, come here, go in, go from the line, then go into the load IA. But this one not the same. IA come in, separate the two. So means you need to apply formula for current right now. So this one will be voltage value will be 208 angle 30 degree. So see, it actually use this 208 original value, just that angle 30 degree, because as I say, they want to fix AN be 0 degree. Then divided by this IA. So apply to IA value. This one. Okay, IA is actually, if you need to use formula, you only have two formula, one for V, one for I. So not the same current means you have to use formula. Then you look at this formula. So IA you have already. Then AB. So you need to move around the formula. IA divided by sub 3 angle negative 30. So IA will be IAB here. Sorry. So it will be IA divided by sub 3 angle negative 30 degree. So you put in IA, just now IA here, IA 10 angle 90, 10 angle, which is 10 angle negative 90 degree. So you're divided by angle, so 3 angle negative 30 degree. So you basically, you get your IAB, and then VAB divided by this IAB value, then you get the answer 36.02 angle 90 degree. Okay. So this IAB value, after you calculated out, it should be 5.774 angle negative 60 degree. Okay. Must always be negative, and it can be plus, but there is a reason. Don't simply Wait. Let me open the lecture notes. There is a reason why chapter 2B or 2A. You need to look at it is clockwise or anti-clockwise. 0 degree, negative 120 and plus 120. Yeah, so you need to know whether like this. So if it is clockwise, they say ABC sequence or ACB sequence. ACB sequence will be anti-clockwise. Turn this way. So if it is clockwise, then AN will be here. Means your phase A is here, then B will be here, C will be here. Understand? A will be here, so you need to the value of A you need to minus 120, so you get BN the angle. So here, negative 120. So if you want to get C here, then you this way lah, you plus 120, I think. Yeah, plus 120 or minus 240. Nicholas, can you understand what I mean? Okay, 0 here will be as a reference. This way will be minus 120, then this way will be plus 120. Okay. Then John, why you say what the J12 times 3? What is J12 times 3? Clockwise. Clockwise plus, yes. Why 208? Clockwise is positive sequence. Yes, clockwise is positive sequence. According to this, clockwise. Yeah, A, B, C, clockwise is positive sequence. And A, C, B, in clockwise, but then it is A, C, B, that means it is negative. Or you put it A, B, C will be, wow, very confusing. A, B, C will be anti, right? Anti-clockwise. But clockwise or anti-clockwise thing is actually not now. Clockwise and anti-clockwise thing is later on in chapter 5, I think. Yeah, Nicholas questions 208. What is referring to? 1 minute, give me 1 minute. Sorry, I have something to settle just now. Okay, I'm back. So what is your questions? Phasor sequence, yes. So what's your problem? Clockwise is positive sequence. Yes. Clockwise is positive sequence. So you look at your ABC. If your ABC is in clockwise direction, that means it is like this. BAN 0 degree, BN negative 120, CN will be plus 120. Okay. So if it is ACB sequence, clockwise ACB or anti-clockwise ABC, that means your AN will be this, C will be negative, and then B will be positive. In the sense, you can see your B is negative, right? C now is negative 120. What do you mean by clockwise not negative? Can you see if it is clockwise, that means supposing it's BN, but now you come first, CN come first. That is what they want to tell you. Colin, can you understand? Supposing it's ABC, now it's ACB. The value here is actually the same. Just that ABC, ACB. But don't worry, normally we'll ask about clockwise. Okay. Then back to Nicholas' questions. So 208 is referred to, why 208 is referred to AB and not AN again? It is because, maybe I show you. Something like this. This is not yeah, something like this. So it is because normally our source is referring to AN. Okay. Yeah. Then we have the line, so we can call this IA, IB, and IC. So we have line. Then this will be our load, so we have source, line, and load. Okay. Then normally if they didn't state the source is delta or Y or delta connections or delta connections, then means that it actually refer to line voltages, because you only need to have, like what I say, you only need to have line voltages then in order to solve the load. Understand? You actually not jumping from load source to load. You are from source convert to line, then line use in load. Can you understand what I mean, Nicholas? So that's why this 208 is actually line to line voltages. Okay. Although it says source, but it actually is not from source. It means it is from line. So unless they say that, unless they give you a very, very clear diagram like this, or they say, this is what source is delta or Y, then you know lah. Then you know that is a source. So you know that you need to convert or not to convert. Okay. The line voltage between the ABC and the neutral line. The line voltages means the line to line voltages. The line voltages I mean here is actually line to line voltage, means here. Yeah. Now line here. AB, VAB, VAC, or VBC. Okay, it's not it's not the neutral, it's not related to neutral. Okay, AB or BC or AC. So normally we look at AB, because we do per phase analysis, we look at only one phase. So AB, that means if AB here, so you see if it is a delta load, it means you can straight away use the AB load, you don't need to convert. Understand? So if it is a Y load, it is a Y load here, that means your AB is here, AB is here, so you need to convert, use the formula to convert to AN. Can you understand? Okay, Nicholas. The neutral line exists, on this line, the neutral exists, but then when we consider line to line voltage or line to line voltage, we don't consider this neutral. We are not consider V line to line. We are not consider V line to neutral, which is ABC and neutral, ABC and neutral line, right? We are not consider AN here or the line. Understand? We are not considering this. We line to neutral is the neutral is only the AN, where is it? The AN here, AN, VAN. Understand? To draw the neutral line or not to draw the neutral line that usually doesn't matter. Okay, because as I said, your line to line voltages, we don't consider neutral line. When we talk about line to line voltages, we means VAB, VC, or CA. Okay. So the calculation is same or not? It depends on whether you are considering AN or AB. If it is AN, that means just now, like just now, the question just now, right? If it is a Y connector load. Y connector load. It means you cannot straight away use line to line VAB here, VAB 208 here. You can't straight away use, right? You need to convert to AN first, then only you use. Okay, so if it is a delta load, that means you can straight away use a AB, VAB voltage, okay, to put in here to do the calculation. Understand? So the calculations, same or not, it doesn't matter with the neutral line. It is related to the load side. It's the delta load or a Y load. Can you feel that I'm trying my best to explain to you all? Nicholas, can you understand now? Why you are so, focused in the neutral line? What is the formula? Then the formula already given in this extra notes. This extra note is in your lecture notes. Okay, 3, chapter, I think it's in your lecture 2. 3-phase. If you want to find VAN, it means what? The Bartlett them VAB divided by sub3 divided by the angle 30 degree. Convert VAB to VAN. Yeah, just move around this formula. Neutral line will change all the derivation? No, not related to neutral line at all. It just, in my concept, it's just, I don't know how others tell you, but then in my concept, it's just, oh, I have VAN here. Okay, then I just drag here, and then I will see, oh, it's the same or not, or they are the same voltages. That means I no need to use a formula. For example here, VN here, then I drag, it's different, or AB here. Okay, then AN is not same as AB, so I use formula to change AN to AB, like that only. Don't you feel it's very easy? Same to your current. Oh, IA here. Oh, IA here, the IA line here, Oh, to the load different, or IA is not same as IAB, right? Then use formula to convert. So if it is the same, it means that just now I load straight away come down IA, and this IAN same, same current. That means I no need to convert, just use the value. So what you guess? Can you understand now? Kind of, that's good. Others? I hope I don't really make you more confused. Then why ask Z delta equals to 3? Oh, yeah. Yeah, we have something like that. What, 3 delta things, right? My brain actually never remember anything. This one. Y load equals to 1 over 3 Z delta. So that Z delta is basically 3 times of ZY. Right, yeah, true. What's the problem? Your brain also cannot. You must remember everything because you are the one who need to sit for the exam. Okay, it's just it's actually very easy. Okay, never mind. We look at next question. Okay, I think I will stop at question 9. Then question 10 you settle. The extra 3-phase questions, I think next time. I think next time should be after Chinese New Year, right? Okay, after this, you can continue to watch the recorded video for lecture 3 and try to do the tutorial questions for lecture 3. Because after this, I think we will meet after Chinese New Year already. Okay? Yeah, right. Wednesday, no class, then no more. Okay. Yeah, this Wednesday offline class. So you watch the recorded video for lecture 3 and try the tutorial questions. And try to settle there's an extra 3-phase question, extra 3-phase question. So you try to do it. Okay. And okay, we continue with our last questions. Question 9. Okay, this question 9, they tell you a balanced delta load. Now they tell you is a delta load. Okay, so with 12 plus, okay, here, okay, 12 plus J9, Okay, per phase is supplied by a balanced three-phase. So this one again, no? Balanced three-phase. So means that you don't know what is that, but then this AB here is actually 208. Okay, calculate the line current. Nah, they want this line current. What is IA? And the total real and reactive power absorbed by the load power factor. Okay, so here these questions the answer is actually okay, it's actually like this. So they want to make yeah, the answer is actually yeah, I can do it two-way for you. What I want to tell you is now they assume this one angle 0 degree. This is from the same book. So now they assume BA this is angle 0 degree. So how are you going to find IA? So normally you want to find IA, right? Then you need to find out the current here, right? The current here, AB. So you use IAB. What is IAB? IAB you can easily use the voltage here, line to line voltage here, because you can just drag and then they are the same, right? So means it is VAB divided by the Z impedance, the load 12 plus 9J. So from here, you will have 208 angle 0 degree. They use 0 degree here. 12 plus J9. So what you get here? I don't have this because this my answer is another the other way, the other method. So it should be 13.87 angle negative 36.87 degree, right? Can you understand this? Can you understand this? 208 source. So 208 source like this one. They didn't tell you is a what delta or Y load, Y source. It is because they tell you this line to line voltage. So you know that this 208 is actually VAB. So you drag here, it means that at the load side AB here that it is the same as this AB. So voltage you no need to use formula. Okay, then but then you want to find current. Is it IA? It is not IA, it is AB because IAB and IA is not the same because IA come in separate into two So IA and IAB is not the same. So we need to find IAB first. It is because Ohm's law easy. VAB voltage here divided by the impedance here, then you get IAB. Then how to find IA? How to find IA? So as I said, not the same all. IA and IAB not the same. Then apply formula. Formula say current formula. IA equals to sub 3 IAB angle negative 30 degree. So sub 3 IAB angle negative 30 degree. So you multiply by sub 3 and then 1 angle negative 30 degree. So the answer that you have will be 24.02 angle negative 66.87 degree. Can you understand what I mean now? Can you understand what I mean now? No matter it's voltage or current, you just drag all voltage is the same, then remain the voltage. Okay, then you can find IAB, and then you find IAB. Then they say they want IA. Line current means this IA. Can find IA or not? Or cannot, it's not the same, right? So you cannot say IA equals IAB, right? So IAB value, then you use formula to find IA. Okay. So this is one way. Okay, so another way will be my answer is actually they convert to ZY. So if they convert to ZY, it will be Z delta divided by 3. So means you have 4 plus 3J. Then That means they convert to Y load. So here will be Y load. So if it is a ZY load here, this is what N, this is A. Okay, A phase. So this is okay for early, this is B. So can you say that now can you say that V AB here, 208 here, 208 here, VAB here, 208 here, 208 here? Is it same as AN? So it's not the same. So that's why you have to find VAN. So what is your VAN formula? Then you refer to this VAN formula, AN here, right? AB divided by SERT3 divided by 30 degree. So it's VAB divided by SERT3 divided by 30 degree. So means it should be, now it should be 1020 angle negative 30 degree. So in these questions, they didn't want to assume AN equals to 0 degree. So they use follow questions 288, they put in 208 angle 0 degree. Understand? In this question, they suka want to assume VN as 120 angle 0 degree. So I purposely want to put in these questions and not to confuse you to let you know you can, the actual way to do it is actually you can assume the angle, what angle that you want, as long as 120 degree apart from each other. Okay, but of course in your exam or test, follow questions. So like this, they put 208, that means you follow 208 angle 0 degree. Okay, can you get it? So that's why your AN now become negative 30 degree. So once you have AN value, then can you find A? Now this IA here is the same as this current across the impedance. So you can use IA equals to what? VAN divided by ZY. So voltage divided by impedance, then you get your current IA, which is same as this answer. Can you understand what I mean now? I think this is a very good question to explain. So we have both way, method 1 and method 2. So this method is I stick back to the delta load, then I continue to do. This way is I change the load to Y load, and then I use a AN way. This one is to change to AN way, and this one is the current change it to IA. Are you okay? If you're okay, can you please type 1? If you need time to digest, then you type 2. Oh, most of you too. Then okay lah, I give you 2 weeks to digest, including your Chinese New Year. Okay, spend your Chinese New Year time to digest this, but actually it's very easy. Okay, if you can understand this, normally these questions in exam, student normally score full marks. Normally, most of them score full marks, because as I say, you only have 2 formula. Okay, and when you need to know you need to use a formula or not. So means you just drag it You can see get like AB then this is AN, definitely cannot use 208 so you said to use formula to convert So this one IA here, sure cannot say IAB same as IA, right? Then you definitely need to use formula to convert. That's it only. Then other than that will be the normal Ohm's law. Of course, formula not given so easy already. Formula still given, then all of you get 100 marks already. No formula in this power system paper. Okay. What I want to tell you so basically you settled question 10, last question, and then the extra. Or do you want to continue? Do you want to continue with the extra 3-phase question? Error credit for solve Ren Jie say want to solve. You want to answer can, yeah. No, last time I don't want to give answer is because I want the students to submit to me. Okay, now I give you an answer so that you can. Actually, it's actually the discussion also very fast because it's nothing. This one, this is actually Y system. Y delta system. Y delta system. Yeah, Y delta system. So the way of drawing is not nice. This one is from another book. Okay, so the answer for this, calculate the V line. V line here is V line here is 1 minute. 1, 2, 40, VAP is this. V line here is magnitude of 1 minute. So 3 times 3, 2, 4, 4. Yeah, 415.69. V line, right? Yeah. An angle 30 degree. And I line will be equals to 199.69 angle 56.31 degree. What 762? Okay. Then question 2. Line currents. So IA equals to 44 angle 53.13 degree. IB equals to 44 angle negative 66.87 degree. IC equals to 44 angle 173.13 degree. Okay. Then question 3. IAC is equals to 117.96 angle negative 98.66 degree M, and IBP is equals to 31.1 angle 171.34 degree. Then this one will be EAN, phase voltages, okay, 254 angle 0 degree. Then IA will be equals to 10.16 angle negative 30 degree. That's it. Okay, any other questions? I will post one assignment in Google Classroom. I think maybe during Chinese New Year lah. No, I think in this week. The one, the submission time is in week 6. So, but then I just think that perhaps can give you more time to do. So I will post it earlier. Are you okay? Or you want to get it after Chinese New Year? Case study assignment. Case study assignment Rubik. Other voltages and not. That one later lah. Voltages or reader to reach topic. Then any question you can ask in Google Classroom. Now this is a individual assignment. Individual assignment. Type return 2050 words and then follow the format. Okay, so that new. I think I need to apply turn in already. I need to apply turn it in earlier. So you need to submit to turn it in. So the report should be score below 30%. Means don't simply copy, okay? Because this is the teacher review type of questions. Okay. Okay. So this kind of story you read yourself. So you are required to write a comprehensive report to discuss about fuel energy efficiency. Energy efficient equipment, okay, used in a factory to achieve energy saving goal. Okay, so you can, this is a title. You can Google, but then the literature review, the rubrics is about the quality of the literature review. So what is the meaning of good quality? Good quality means you give in-depth analysis and clear justification of the problem, systematic research, comprehensive. So it means that Google is not considered excellent. Google should be here. Okay, this range, poor to average range. Okay, So supposingly, you want to write a good teacher review paper, then you need to have from journal papers or some books or some published materials. Okay. Then contribution or novelty. So you have the in-depth analysis and solution provided are completely new and original or something lah, or refer to some system. Then discipline also you can link with multiple parts and draw conclusion, combining example, facts, theory, for more than one field of studies or perspective. So it's not related to any chapter. Yes, it's a literature review to target your the 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 last CLO, the last learning outcome, lifelong learning. So it's about those sustainability of power systems knowledge. Okay. Any question? So means week 6 submit. So I will post the assignment to Google Classroom later. Okay. Later I will upload. This is 50%. Or no, this is 30% of coursework. You have 30% this one called case study assignment, easy busy, and then another 30% of lab report, then 40% midterm test. Okay. Oh, you want to bincang this submission date? Why then? I thought you want early settle better. Week 6 submit this, then week 8 you will be submit your lab report. Week 10 will be your midterm test. So if you want to delay this submission, then you are going to have a lot of things in the end of the semester. No, of course you can enjoy your CNY. This one, supposing I can issue you in week 4, then I give you 2 weeks time to do. But then, I think give you early time to do some research, then also good. So that's why I give you earlier. You still can enjoy your CNY. It's not related to your CNY, just that you cannot call that. No, the problem is I can't delay. The problem of I can't delay is not because of me. It is because of this turning in. Turning in, I need to apply. So I apply turning in, then they will open 1 week for you to check your report only. So this 1 week end already, then means you can't check your report. Turning in means the plagiarism score. That means you are going to have a problem. Understand? So I have to adjust the due date based on the turning in mean application date. Okay, you get what I mean? But I think it's quite okay lah, because week 6 or you want week 7, because week 8 you need to submit your lab report, so that's why I made week 6 for you. So week 6, week 8, and week 10. Roughly like this. But I haven't applied turning in yet. So if you want to adjust later on, I still can play around the time. But then my tentative planning is like this, week 6. So I think it's good for you. You can settle early, then you actually 2,500 word is quite easy to hit. Okay. I'm still thinking midterm test whether I want face to face or what. I think should be online test. Don't want face to face. Okay, then online test. I already said the question. Not that hard, not hard at all. Okay. It's a very simple, straightforward questions that you should be able to answer. Okay, don't talk about the tips and the exam lah. You want to enjoy your Chinese New Year, right? So after Chinese New Year, we will talk about the test. Okay. This report is individual assignment. Sure, I will give some revision before the test. No worry. Okay, remember to give me 5 stars. Okay, any other questions? 5 stars. That's good. Let's see the exercise answer again. See, Nicholas is the one who asked the main point. Nicholas, which question that you would like to see? One and two. What not exceed 30%? Why YouTube? Huh? Don't put my... Oh, huh, Brian, don't put my video in YouTube, leh. Because of... I don't want to put in YouTube because my notes and all those, actually, I didn't change a lot. Private, okay. Don't make it public, I'll kill you. Okay. Private one, private and public. Private one is better don't put in YouTube, lor. Why you want to... The problem is, why I want to put in YouTube? Then means I no need to do the recording for the Google Meet already, right? Oh, actually, I already put the link in question 2. I already put the link in your Google Classroom. There's a link, then you click in, then means all the Google Meet recording is there. Wow, Brian is very hardworking. Oh, that means next time I can't find the video, forgot to do recording, I can find Brian. That's the thing lah. The storage actually, I also can't store. That's why I straight away move the link to the Google Meet only, Google Drive only. I don't want to download it down. Okay, done But then actually, I don't feel you should watch back the recorded video because actually it's very time consuming. Okay. Okay, any questions? If no questions, then we will end our class here and you enjoy your Chinese New Year holiday. I will meet you after Chinese New Year, I think in week week 3, week 4, right? Okay, so yeah, happy Chinese New Year to all of you and happy holiday to Edin. Okay, bye.